Welcome to the channel. Today we shall be discussing about one very important speedometer test, and that is called speedometer resonance test. Let us start with the term frequency. Frequency is the number of vibration cycles per second measured in hertz. In the context of a speedometer or vibration test, if a motorcycle engine runs at 6000 rpm, that translates it to 100 cycles per second or 100 hertz. When testing a speedometer, engineer exposes it to a range of frequencies like 10 hertz to 2000 hertz to see if any of those cause resonance. And resonance is a condition in which an object vibrates with maximum amplitude when it is exposed to vibration frequency that matches its own natural frequency. Every mechanical or electronic component, including a speedometer, has a natural frequency. When external vibrations coming from engine, road, or a test machine reach this same frequency, the component begins to vibrate more violently, strongly than normal. This amplitude vibration is called resonance and can lead to noise, loose parts, structural fatigue, and failure of internal mechanisms. So, resonance is a natural phenomenon that occurs when a system is exposed to vibrations at its natural frequency, causing it to vibrate with maximum amplitude. Like explained earlier, every physical object, needle, casing, internal components, has its own natural frequency, the frequency at which it prefers to vibrate. If the motorcycle generates vibration from the engine, road, etc., that matches this natural frequency, the part can resonate. Therefore, excessive vibration or oscillation in that part, which can lead to wobbling needle, display instability, component fatigue, or failure. Its analogy, think of pushing a child on swing. If you push at just the right time, resonant frequency, the swing goes higher with the less effort. Same concept applies to vibrations and components. As we have discussed, vibration frequency is the input, that is, vibration per second, and resonance is the amplitude output response when the frequency matches the system's natural frequency. For example, suppose the needle shaft in a speedometer has a natural frequency of 120 Hz, and when the motorcycle engine operates in a mode that produces vibration around 120 Hz, the needle begins to oscillate violently. This is resonance that at that specific frequency. The resonance test for a speedometer evaluates how the speedometer assembly responds to vibrations, particularly those the motorcycles naturally generates during real-world use. The vibrations coming from engine vibrations, roads and bumps, etc. The purpose of the test is to identify the resonant frequencies of the speedometer components. To ensure structural and functional integrity under real-life vibration conditions. Number three, to prevent issues like loose or buzzing parts, needle fluttering or getting stuck, display errors for digital displays, digital speedometers, cracks or component fatigue. How it is done? Mount the speedometer as it would be on the motorcycle on a vibration table or shaker. Run vibration sweeps typically sinusoidal over a range of frequencies, for example, 10 Hz to 2000 Hz. Then measure the amplitude of vibration, response of the mechanical parts, that is, needle and casing, etc., any structural failures or malfunctions. Critical frequencies or the resonance points are noted. Design change may be made to dampen the response, shift natural frequency out of the motorcycle's operating range. Example, if a speedometer needle starts fluttering wildly when the motorcycle hits 4000 rpm, it could be responding at the same frequency as the engine vibration at that particular RPM. A resonance test would help catch this issue during development, and engineers could reinforce the internal structure or dampen the needle mechanism. Now, coming to real-world example related to resonance test. This test is crucial for high vibration environments like motorcycle, where components are exposed to constant mechanical stress. Now, the relevant standards for vibration testing in automotive components. While specific standards for motorcycle speedometers may not be explicitly outlined, several automotive standards provide guidelines for vibration testing of electrical and electronic components. Number one, ISO 16750-3 of 2012, related to road vehicles, applicable environmental conditions, and testing for electrical and electronic components. Overview of this standard is: this standard specifies requirements for testing the mechanical loads that automotive components, including electrical and electronic equipment, must withstand. Vibration testing. The test outlines the procedure for vibration testing, including the frequency range and acceleration levels that components should endure. Its relevance is, although it primarily focuses on automotive application, the principles can be applied to motorcycle speedometer to assess their resilience to vibrations. Now, coming to ISO, the another important standard, ISO 16750-1 2023, applicable to road vehicles for environmental conditions and testing for electrical and electronic equipment. This document provides general requirements for the environmental conditions and testing of electrical and electronic equipment in vehicles. Vibration considerations. While it does provide specific vibration profiles, it emphasizes the need for components to withstand environmental stresses, including vibrations. It is relevant and it serves as foundational standard for understanding the environment challenges that components like speedometer may face. Applying these standards to motorcycle speedometers. To conduct a resonance test on a motorcycle speedometer, manufacturers can adapt the vibration testing procedures outlined in these standards. Number one, test setup. Mount the speedometer on a vibration table that simulates the conditions experienced during motorcycle riding or motorcycle operation. Expose the speedometer to vibrations across the range of frequencies, typically varying from 10 Hz to 2000 Hz, to identify any resonance frequency. Apply acceleration levels that mimic those encountered in real, real-world motorcycle use. Duration of the test. Conduct tests over extended periods to assess the long-term durability of the speedometer components. By adhering to these guidelines, manufacturers can ensure that motorcycle speedometers are resilient to vibrations and perform reliably under various conditions. With this, we conclude our discussion on the subject of automobiles, motorcycles, and scooter speedometer resonance test. Thank you and thank you very much.